Okay, hello ladies and gentlemen, happy Friday. I apologize that I cannot be here with you today to talk about what's going to be a very exciting topic for us, ladies and gentlemen. It is roots of higher order polynomials. This is really just the beginning of what will take us a few weeks to discover all the patterns and tricks that we can use to find the roots of things like x cubed and x to the fourth. And part of that process, if you have the notes in front of you, will involve taking something in expanded form, like you see in the column on the left, and trying to write it in a factored form. And you can see there's also that column for quotient form. At the very top of that chart, you can see that we can do this for numerical values, like 15, what it looks like in a factored form and a quotient form. But what we're mainly concerned with here is how do we do this for things like quadratics and then eventually cubics. So for the quadratic in the middle, that should be pretty easy for us. X squared plus 6x plus 8 factors into x plus 4 times x plus 2. So we're going to factor that as so. And then when it gets to the quotient form column, what we can do is we can say, all right, if I take the original quadratic, x squared plus 6x plus 8, and I divide by one of those two factors, doesn't matter which one, let's say I divide by x plus 4, that the remaining factor is x plus 2. And clearly, if I have factors of x plus 4 and x plus 2, that would result in roots of -4 and -2. Well, when we do this for cubic polynomials, the tough part is that it may not always be factorable by, let's say, a technique similar to grouping. So what we're going to do for now is I will tell you a root to start, and if you look in the very right-hand column for the next one, we know that x equals 2 is a root. So if x equals 2 is a root, that indicates to me that x minus 2 is a factor of that polynomial. With that knowledge, what I want to now do is say, hey, if I have x cubed plus x squared minus 10x plus 8, and I divide that by x minus 2, what is the quotient that's left over? And we're going to do that down below. So it says, how can we find the other roots of the third degree polynomial given in the chart? Well, we're going to actually take a look at a polynomial division process that allows me to figure out what's left over from that division, and hopefully that will lead us to the other two roots. So if I go ahead and set up some long division, this is something that you would have seen last year. So I'm going to take x minus 2 and divide it into x cubed plus x squared minus 10x plus 8. If I was there, I would be expecting to hear some moans and groans right about now. So go for it. I'll give you 5 seconds. Okay, very good. So then you're going to take x cubed and divide by x. This is how you get started. Okay, you're sort of asking yourself how many times does x go into x cubed evenly? And the answer is that we're left with x squared, right? So take the first term underneath your division here, x cubed, divide by x on the outside to get x squared. The next part in the long division process here is we take x squared and you multiply by x minus 2. So when I do that, I get x cubed minus 2x squared. After we go through the process of multiplying, then long division would say to subtract that quantity from what we have above. So we have x cubed minus x cubed cancels, which is perfect. And then from there, we have x squared minus a negative 2x squared. So guys, that negative actually has to carry over to the second term there, so just be careful. If you subtract a negative, technically now it becomes plus 2x squared. So the result there is 3x squared. Okay. And before I start this process over again, the very last step in long division is to bring down the next term, which is negative 10x, and then start all over again. So now we're going to say, okay, well, how many times does 3x squared go into x? Sorry, how many times does x go into 3x squared? So if I take 3x squared and divide by x, that leaves me with positive 3x. Okay, so take your term here, 3x squared, divide by that x there to get 3x as the result. Now you take 3x, multiply by x minus 2 to get 3x squared minus 6x. Okay. Subtract that from what you have above. 3x squared minus 3x squared cancels. And again, when I subtract negative 6x, it might be nice in this case to say, oh, we're really adding that 6x, so negative 10 plus 6 is negative 4x. And the last step is to bring down your plus 8. So if I take negative 4x, divide by x, that leaves me with minus 4. And from there, if I take minus 4 and multiply it by x minus 2, we get negative 4x plus 8, such that when I subtract that from what I have above, you'll notice actually that both of these cancel, and I'm left with 0. Remember that 0 in the end right now is my remainder. And the nice thing about having a remainder of 0 is that that implies that the factor x minus 2 divides in evenly to that cubic polynomial. Okay, so x minus 2 is in fact a factor of that polynomial that we started with. So where that question mark was before, I can actually now change that to saying, hey, I know that our quotient is x squared plus 3x minus 4. Sorry, it's a little tight for me to squeeze in on this fancy smartboard screen here, but so that's actually what can go in this spot as well. That's a factor form. Okay. Now here's the thing, it says how can we find the other roots though? So we have this quadratic that's left over. Do we know how to solve quadratics? Well, we better know how to solve quadratics because we just did an entire unit on it, right? So take x squared plus 3x minus 4 equals 0 and see if it's factorable. If not, you know other techniques that would allow you to solve this. So it breaks down to x plus 4 times x minus 1, which leaves me with roots of x equals negative 4 and x equals positive 1. Okay, so if I go back up to the chart, those are the other two missing roots that we can now fill in, x equals negative 4 and x equals 1. Okay, so we know that that cubic crosses the x-axis in those three locations, 2, 1, and negative 4. If I go back for a moment and talk about how you all were maybe groaning a few minutes ago when we did long division, there is a simpler way to do this. Okay, so long division is not something we will typically use. I wanted to show you and remind you what the process looks like, but guys, to be honest, I'll probably never use long division again. So the simpler way that you'll all be very excited to use is called synthetic division. Now I'll show you what that synthetic division looks like as you guys are getting caught up to me in the notes, because I realize I might be going a little fast here. Definitely hit pause every now and then if it's going too fast. All right, so we have synthetic division. The way synthetic division works is if you want to divide x minus 2 into that cubic polynomial, what you do is you, on the outside, we know that one of the roots is x equals positive 2. So I want you to put a little sort of half box around 2, which is the root that we know. And then I'm going to write 4 numbers down, and I think you'll know what these 4 numbers represent. Take a second and see if you can figure out where 1, 1, negative 10, and 8 come from. Okay. So those are the coefficients of the cubic that I'm dividing into. So what we do is, the first thing is bring down that 1 to get started. And the synthetic division process works by multiplying by what's in your little box, which is that 2. So 1 times 2 is 2. And then you add that to whatever's above. So the 2 plus that 1 above it is now 3. And then you repeat the process. 3 times 2 is 6. Add that to the negative 10 above to get negative 4. And finally, negative 4 times 2 is negative 8. And negative 8 plus 8 is 0. Okay. So at the end, that last number that I boxed off here, guys, that's your remainder. And what you'll find is that these 3 numbers that you're left with right here, those should also look familiar from just a second ago. Weren't those the same coefficients as this quadratic over here? So this will always be your remainder, the very last number, and then if you're dividing a linear term into a cubic, you're always going to be now left with a quadratic. Okay, so that's the quotient from that process, and then our goal eventually will be to continue to find the other roots by factoring or other techniques. Today what I'd like to do is just get more practice with the synthetic division process now that we've seen how that example works. I'm assuming if I asked how many people like this way better that I would see everyone's hands up. That's just my assumption, but I'll check in with you guys next week to see what the final tally was for the vote. So on the back, there should be nothing, because you're going to take some more notes back here, and if you run out of space, you guys can certainly find another sheet to go ahead and take some more notes on. So for synthetic division practice back here, number 1 will be, let's take x cubed plus 2x squared minus x plus 5 and divide by x plus 1. Okay. In order to do this division, what we're going to do is consider that when I divide by x plus 1, we want to put that root in the box. That's going to be the number that we eventually multiply these coefficients by. So if we're dividing by x plus 1, that means that we're sort of like testing -1 as a root of this cubic polynomial. So we put -1 in that little half box, and then the coefficients of the cubic, 1, 2, -1, and 5, copy those down. And we're going to start the process that we just saw a moment ago in the last example. So we always start by bringing that first number down. So when I bring down the 1, 1 times -1 is -1, plus 2 is +1. Okay, repeat the process. 1 times -1 is -1, plus the -1 above it is -2. And finally, -2 times -1 is 2, plus the 5 above it is 7. That 7 that we get at the end is a remainder. Now, what we should notice in this particular example, and I mentioned this briefly a moment ago, is that when you get a remainder of 0, we like that, because that means that x plus 1 is a factor of the cubic polynomial. However, if you get a remainder of 7, the conclusion is that x plus 1 is not a factor of the cubic polynomial I was dividing it into. You have to be left with 0 as a remainder in order to conclude, yes, x plus 1 is a factor. So if I ask you to write the quotient, what you have is that the quotient is, you can still write it as a quadratic, x squared plus x minus 2. That's from looking at these 3 coefficients. And the remainder is 7 over what we divided by, which is x plus 1. So the official quotient has this remainder piece to it. Eventually we'll be looking for things that don't have a remainder, so that this way we can continue to solve. But for now, the questions might just say, what is the result from doing this division? And in the end, it may not be a factor, and we'll go from there. Okay, let's try another one. So for number 2, we're going to take x cubed plus x minus 3 and divide by x minus 2. Okay. This one automatically looks different than the other examples, and if I asked you to consider for a moment here why it's different, I'm guessing hopefully somebody would have shouted out that this one has no x squared term. Okay, we're missing an x squared. So how that affects the process is I'm still going to say, hey, if I'm dividing by x minus 2, that means we're sort of testing if x equals positive 2 as a root. And when I go to list the coefficients of this cubic, I know that 1 is the coefficient of x cubed, but we need 0 as a placeholder for x squared. So one important part of the process for synthetic division is if you are missing terms, you do need to account for them with zeros. And that's something we can easily forget. But if I put a 0 as the placeholder for x squared, bring down 1. 1 times 2 is 2. 2 plus the 0 above it is 2. 2 times 2 is 4, plus 1 is 5. And at the end, 5 times 2 is 10. 10 plus -3 is 7, okay, which again is our remainder. So the conclusion in this case, just like we had in the last case, x minus 2 is actually not a factor. And if x minus 2 is not a factor, what that means is that 2 is not a root of this polynomial. So factors and roots get connected in that way. So similarly, I might actually ask you the question here, is 2 a root of x cubed minus 5x plus 2? So I would just test it with synthetic division. And if I'm answering this question correctly, I'm going to confirm whether or not the remainder is 0. Okay, so I'm going to take the coefficients from that cubic, which are 1, 0, -5, and 2. Right, we have no x squared term again, so we have to put 0 as a placeholder. Bring down the 1. 1 times 2 is 2 plus 0 is 2 times 2 is 4 plus -5 is -1 plus times 2 is -2 plus 2 is 0. Sorry if that was fast. Okay. Is it a requirement that you put a smiley face when you get a 0? The answer, yes. You have to be happy when you get zeros. That is the whole goal of this unit. So, based on that, we know that a remainder of 0 indicates, yes, 2 is a root. Yes. Okay. So we have to confirm that based on that remainder, we say yes or no. All right, let's do one more, and then you guys can get started on the homework. The homework this weekend is a worksheet plus a little bit of textbook homework, so please make sure that you pay attention to the calendar. Last question we'll do is 2/3 a root of 54x cubed, I know you're nervous already, minus 27x squared, minus 27x plus 14. Oh boy. Okay, this looks scary, but it's not. So I'm going to test 2/3 with the following coefficients, and we'll see how good we are at testing a fraction. Okay, really stepped up our game a little bit here, so we're going to bring down 54. I guess you could use a calculator to help you if you need it, but 54 times 2/3, I would say, hey, you know what, let's say that 3 goes into 54 18 times, and that 18 times 2 is 36. So that might actually be a quick way to evaluate 2/3 of 54, but use a calculator if you get stuck. So when I take 36 and add to -27, I get 9. And then 2/3 of 9. Let's see, 3 goes into 9 3 times. 3 times 2 is 6. Add it to -27 to get -21. 3 goes into -21 to get -7. And -7 times 2 is -14. Okay, the remainder is in fact 0, so therefore 2/3 is a root. Okay. We will definitely be doing synthetic division from here on out, guys. So if this was confusing at all, rewatch the video over the weekend. Otherwise, I will catch up with you on Monday. I hope that you guys have a fantastic weekend. And more good stuff with hops to come next week. See you then.